We welcome your questions. I believe we're going to answer some if we have them at the end of this webinar, but if for some reason we don't get to your question or you have a question later, you can always submit them to us via email at questions@wll.com. And now, I'd like to introduce our presenter. Jennifer Sanchez has over 20 years experience in the EMC wireless industry with 15 years of post-market surveillance experience. Jennifer currently manages American certification body ISO 17065 post-market surveillance program and is a technical reviewer for FCC, ISED, and Japan wireless certification. Jennifer has worked for test labs, certification bodies, manufacturers, and started a consulting business before joining ACB in 2014. Jennifer enjoys traveling and exploring new places, meeting new people from around the world, and discussing philosophical ideas. So, without further ado, let's turn our attention to North America Post-Market Surveillance Introduction with Jennifer Sanchez. Hi, Jennifer. How are you today?
I'm good. Thank you, Kim. Okay. Can you see that, Kim?
There it is. Thank you.
Okay. Thank you. I would like to thank Washington Labs and ACB for giving me this platform to share this information with you all. And I would like to thank the participants for taking the time today to listen to this presentation. And I hope you gain some incitement and information that will help you in your career. So, as Kim said, my name's Jennifer Sanchez, and I've been in the industry for 20 years. I've worked for 3 different labs, 4 different TCBs, and 2 different manufacturers. So I've been on all sides of this. In the last 15 years, I've been dealing heavily with surveillance. I've added this quote from an anime that I really enjoy. It's the greatest illusion of this world is the illusion of separation. Things you think are separate and different are actually one and the same. We are all one people, but we live as if divided. And the reason I put this in here is because I noticed in our industry, we believe that we have one role, and sometimes we forget to look at the big picture and realize that we're all in this for the same goal. So my hope is by giving you that perspective that it will help you. So in this presentation, we're going to cover post-market surveillance for FCC and ISED. We'll discuss the rule parts and standards which require surveillance, the roles and responsibilities, what's involved with surveillance, how to prepare for surveillance, and then failures. What is considered a failure, how to address those failures, and what some of the root causes may be. And I'm happy to take any questions during the presentation or after, and you can also email me directly, and I will give you that contact information. So let's get started. So what exactly is post-market surveillance? Post-market surveillance is the inspection of certified wireless consumer products once mass production has occurred and it's released to the public to ensure continued compliance. Requests for samples are from the certification bodies which issued your certification for FCC and ISED. Only the TCB which issued your certification may request a sample for surveillance, with the exception that the FCC or ISED may do a direct request. But that's very rare. And then TCBs are required per RSP 100 Section 12.2, FCC Part 2.962G, and ISO IEC 17065 Section 7.9. All of these rule parts talk about surveillance and the requirements. And we have to audit 5% of our annual certifications, with 1% being SAR. So I've pulled up the FCC rule parts that pertain to surveillance. So from a TCB's responsibilities, a grantee's responsibilities, and then the KDB that TCBs will follow. I've also included the ISED standard. There's not as much information as there is for FCC, but in RSP 100 is where it talks about surveillance. And then I've taken the information from ISO 17065. I get a lot of requests for, well, where does it say in the rule parts that we have to do surveillance or that you have to choose our product? So I find it easier to just provide these links when I send out the request. So there are three main roles when it comes to surveillance. Obviously, the manufacturer who's making the device, the test lab who originally did the testing, and the certification body who issued the certification for those products. So I want to go into each role. So for manufacturers, as the manufacturer of the wireless consumer products, it is your responsibility to ensure continued compliance of all your products on the market. So some examples of that may be having a factory that's ISO 9001 certified, or the manufacturer is certified for 9001, which is a quality assurance certification. Doing pre-certification testing, spot testing the products after mass production, just basically quality control procedures, So those are ways to continue compliance. You need to maintain easy access to your certified products for when audit requests are issued. So if you're going to have, depending on what your product is and how you sell it and distribute your product, may determine how easily you have access to those products. So if you're going to have restricted access to those devices after post-market or after production, you need to let that be known during the original application process. In addition, you need to have a Canadian representative if you are importing into Canada. They will be, usually they are contacted by Canada directly if they want to audit a product. I like to copy the Canadian representative when I send out requests in the event that I can't get a hold of the grantee. The manufacturers need to respond to these requests within 21 days per the FCC requirements to avoid the grantee code from being blocked. If your grantee code gets blocked, this will stop importing, exporting of your goods. So it's very important that you respond to the request within the 21 days. You need to prepare a sample to be inspected by the TCB, and samples should be configured for testing with clear, detailed setup operating instructions. And the sample should include the user manual, the packaging as the end user would receive. If the product is sold in bulk or professionally installed or to OEMs, let the TCB know that, that when they get the sample, it's not really going to be how an end user would have it. And so that way there may not be packaging or a user manual, or maybe your user manual is online. So you need to let them know that. You need to provide technical support to the TCB for the test setup, the operating of the EUT. And this will kind of help avoid delays or a bunch of back and forth. And then, keep an open communication with the TCB. Be honest, be cooperative. In the long run, it's definitely going to help you out. So for test labs, it's the test lab's responsibility to ensure that they're performing testing in accordance with the rules and the standards. And if they're making any type of deviations, that should be well documented in the test report. And test labs must accurately and clearly document the test setup, the test procedures, the test equipment, deviations, and the software that the EUT is being used with. This is very, very critical because, when an engineer is testing a product, they're testing so many different products, and sometimes they may not record what the test software was being used, what the settings were, but you have to think ahead and realize that, is this going to be able to be reproduced by somebody else in the future? So the more information that you provide and document, the better in the long run, because you want to be able to repeat those original results in the way, the best possible way that you can without having to make deviations. So documentation is very important from a test lab's perspective. Most test labs do act as the agent on behalf of the manufacturer, and I find that when this happens, a lot of times, because the agent is dealing with the TCB or the certification body, that some information can be lost. Maybe, the agent's fully aware of these things, but maybe that's not being passed on to the manufacturer. It's assumed that they already know. So it's important to keep that communication open and ask questions and make sure that you're relaying any information that a TCB is telling you to the manufacturer. And then test labs should educate their clients of the responsibilities and the importance of continued compliance of their products. Don't assume they already know what they need to do. And then the certification bodies. So, the TCB has to audit 5% of their annual certifications every year, and 1% containing STAR. Recently, the TCB Council made a proposal to the FCC and ISED to change the requirements that the 5% will be based on a previous year certifications as opposed to the current year. Right now, the way it is that TCBs have to audit 5% of the current year. So, for 2020, I'm not going to know the final amount until January 1st of 2021, but I have to estimate how many I think we're going to certify and audit that. It's a moving target. It's very hard to keep up with that, and a lot of times TCBs may get an increase in certifications, and so that bumps up their requirements and how many they need to audit, and so you may get requests later in the year. So our hope is that by having the fixed amount, you already know it by January 1st, you already know how to prepare for the rest of the year, and you don't need to try to make up any audits. So when TCBs select samples, they go by the KDB 610077 guidance, and I've added this here. So if you're a new manufacturer, you could be audited, not because you've done anything wrong, it's just you're a new applicant, you're new to the industry. New technologies, products with a history of noncompliance. So if you've been known that you've had some problems in the past, products where test reports may be sufficient for approval, but raise questions for continued compliance. And this one is mostly for products where you've passed all the limits, but maybe you're very, very close to those limits within a few dB. That can raise a flag. So just be mindful of that. So TCBs have to create a test plan for the audited product. They have to inspect the label, the user manual, the internal components, the external components, or the host, the antennas, if there's any external antennas, and the housing to ensure no modifications have occurred that haven't been documented. TCBs will issue a findings report summary, and they will compare that to the original report or results. They'll take photos and then inform the FCC or ISED if there's any noncompliance issues. And this includes labels and user manual failures, not just test failures. TCBs must also, they have to complete all their testing and their reporting by December 31st, and then submit a findings report to the FCC and ISED by January 31st every year. So that's the TCB's responsibilities at a minimum. So when you get a request for surveillance, how are you going to prepare for this? So when a sample is requested for surveillance, the manufacturer has to provide the sample from a recent production run to the TCB within 21 days to avoid issues. Now, the FCC does allow the TCB to be flexible with this. And I think as long as you respond and you keep an open communication with the TCB and let them know when you will be able to get a sample, you'll be fine. But you need to respond as soon as possible as far as acknowledging that you have this request and that you're working on it. And then depending on the technology and the complexity of the device, it may be required that you have to provide several samples. Typically speaking, though, you're going to have a production sample, which is basically unmodified. It's how the end user would get it, and its final packaging, labeling, manual, everything. And then you'd want to provide an engineering sample where that's the one that's going to actually be tested. So that one obviously needs to be modified with test software so the TCB can test it. You cannot provide the original test sample that was used during the certification process. That's not allowed. The only time you would need that or use that is to compare to the audit sample if something went wrong. So as a manufacturer, it's very important that you provide clear and detailed instructions to the lab for setup and configuration of the product. So you have to realize that it's very possible that the engineer that's going to do the audit testing has never seen your product, doesn't know what it does, not familiar with it. So you'd want to provide them step-by-step instructions to test the product. And that way they don't have so many questions or, the delays and trying to set it up. And then provide contact information to help them through that process if they need it. The TCBs need to provide clear test plans to the engineer to make sure they're not doing any additional testing, unnecessary testing. Just give them very clear test plan. And then the test lab, they need to follow that test plan, obviously, or the test labs need to follow that test plan and make sure they review the original test report so they know what was originally done and try to replicate that test and see if they get the same results. So when in surveillance, what we have to typically do is, obviously we're testing the product, but we're not doing a full scope testing. It's purely spot checking. So power, frequency range, band edge, and spurious harmonics. They also have to inspect the label, the user manual, and the external and internal components, and then compare the audit results to the original certification results, including the internal components and any label changes that might have occurred. And then work closely with the manufacturer and the test lab to resolve any failures. The TCB will issue an audit test report, which the manufacturer can have if they desire. And then if there's no failures, there's no problems, the samples can be returned or destroyed, and there's no further actions needed from the manufacturer. The TCB has to continue with their reports and notifications to the FCC and ISED, but as far from a manufacturer's perspective, there's no failures, test reports done, they're done. So if there are failures, they can occur on many different levels. So there's two main failures that a TCB is looking at. One is, obvious. Is it failing the limits for FCC and ISED? And then, is it failing in comparison to the original results? I think a lot of manufacturers don't realize that this is something that TCBs look at and could be considered a failure. Even if it's meeting the limits, but there's such a large difference between the original and the audit sample that it would be considered a failure. So a lot of those failures usually happen on band edge, spurious emissions, pretty common, and power. And so when this happens, it's very important that the test lab and the TCB confirm their test setup, confirm the configuration is correct, that the test software settings are correct. And if possible, you may need to use another site to confirm those settings or the results. But once a failure is confirmed, the TCB has to notify the FCC and ISED immediately and then start the investigation process. And the FCC and ISED expect to be provided with the details of the failure, why the failure occurred, how the failure will be fixed, and how many units are out in the field with this failure. So there's a lot of information that needs to be addressed, and I typically like to have all of this up front before going to the FCC to avoid delays and a bunch of back and forth. So depending on the failure, there's a few actions that will probably need to occur to resolve. Typically, depending on what, if it's a testing failure, a Class 2 permissive change will probably need to be filed. If it's a label or issue, then a Class 1 permissive change could be filed for Canada. You may need to reconfigure units out on the market with over-the-air software updates. You may need to recall and replace those units out on the market, or you may need to dismiss or revoke your certification if, and this is only allowed if no units have been sold in those countries. But if they have been, then you won't be able to typically dismiss or revoke your certification. And these are just possible outcomes. So, having been doing this for 15 years, I've noticed a trend when it comes to these failures, and what happens and what's causing them. And I've laid out 3 here that I think are the most common. So I would say internal component changes is a big one, model name, label changes, and software. And so many times there are internal component changes made to the product after certification was issued, which can really be the root cause for a lot of the failures. So a manufacturer may not fully understand or may not find it financially feasible to test the product every time they make changes to the device, especially if it's what they believe to be maybe the digital portion or not related to the RF portion. So these changes can affect the RF portion of the device, even when they're not intended to. So manufacturers need to verify, document the changes with testing. They don't need to go to an accredited lab. They can do internal testing themselves just to document and show that it still meets the limits. There's not a big difference. And that would be considered a Class 1. Now, if they are seeing big differences, then they need to do a Class 2 permissive change, and that would need to be tested at a accredited lab. Another issue is model name label changes. So a lot of times a draft label is provided for certification, and it's intended for North America. But, when it comes to production, a lot of times all these other countries' requirements get put on that label. And so, to save cost or save space, some things may get dropped off the label. And a lot of times that's the model number, or they change the model number in some way, or they add it to a different part of the label or a part number. And so, that's considered a failure if it's not the same way. So that's a very common problem. And then software changes. And this is usually because during original testing, maybe the manufacturer had to go to a third party to help with the test software for the transmitter, or maybe it wasn't documented what the settings were at that time. So then when it comes to audit, the manufacturer has no idea what was used, they don't remember, or that engineer that handled that project is now gone. So you run into those problems. I've added 2 links here, one for the FCC permissive changes requirements, and then also for Canada's modification requirements. So if you need to determine if you're under a Class 1 or a Class 2, these rule parts will help you decide. So for internal component changes, so A lot of times, manufacturers have to change maybe the layout or some of the components of the product for mass production. This needs to be investigated when they do this. You have to remember that the whole product is certified, not just the transmitter, unless you're just a module, but it's the whole device that is certified. So whenever you make any changes to any part of that device, document it. Make it clear that you've done your due diligence to ensure compliance. A lot of times there may be variants under one ID, which is allowed, but you need to document that obviously in the application. But when you submit a sample for surveillance, you need to let the TCB know which variant you are providing. So that way when they do a comparison, they understand why there's a difference in maybe the layout or the components or the operation. So I give examples here of component changes that resulted in failures. So we had an audit sample. It passed the band edge limit, but it was nearly 40 dB higher than what the original band edge results were. And this was a huge difference. So going back and forth with the manufacturer, they had made some design changes to the layout of the product. In their minds, it didn't affect the RF portion because it wasn't related to it, but it did affect the band edge, and so they had to file a Class 2 permissive change to show compliance. We also had another sample where we did an internal inspection, and there were differences from the original layout. And during that investigation process, the manufacturer realized they had provided us with a very old version of the product that they don't mass produce. So all the testing that was done for audit had to be redone because it didn't represent what was being sold. So label changes. So many manufacturers will change the HVIN or remove the HVIN from the label during production for various reasons, like I said. So ISED pays very close attention to this. You know, FCC, they don't particularly care for the model. It's not something that they're going to monitor the way Canada does. So, you know, you got to be mindful about this. So if you can change your HVIN, there's no problem doing that, but you need to file a Class 1 permissive change with Canada every time you do this. Or if you know that you're going to be using multiple HVINs in the beginning, it's best to provide that during the original certification. So I give an example here of how a label is submitted, how it should be. You have a company name, you have a model. You don't have to say that, you don't have to put the prefix that it's model or HVIN. You don't have to do that. You just got to have the model number on there. And then the IDs, of course. But then come post-production, the label changes and you're trying to fit everything on there, so you move maybe the model number to the part number or somewhere else, and that's not easily identifiable to the end user. And that's the purpose. The HVIN should be easily identifiable on the label to the end user. Your HVIN is basically your model number. Your PMN is your product marketing name, so that's something that you're using for maybe online or in your manual, but the model number needs to be on the label. So the FCC requires that the ID format be contained on one line, so you can't separate it to try to make room. ISED requires IC, the prefix IC, but they will accept ISED or similar formats. FCC does not. You can only do FCC ID. You can't do anything else. And the FCC Part 2 statement should be on the label. It doesn't need to be next to the ID, but it should be on the label on the product. If for whatever reason that you can't fit it on there, then it would go in the manual. And then I give the links here to Canada and FCC rule parts that talk about labeling and the requirements for that. So you can review that if you have any questions. So here's some examples of situations that we've come across. We had an audit sample that was labeled with different model numbers. There were 3 samples provided, and each had a different model number. I thought this was strange because they're all very similar. There's really no difference in them looking at them. So during the investigation process, this company had 16 variants of this product. So they had 16 different model numbers that they were using. And they were not aware that they couldn't do this and that they thought what they were doing was fine, but it wasn't. So they needed to file a Class 1 permissive change with ISED to include all 16 of these variants. Now, ISED charges for these HVINs, so that got, pretty costly. So, just be mindful of that. Another situation we had was the label, or the product was labeled with a different HVIN. So the HVIN changed by 1 digit. And, talking to the manufacturer, what they were doing was for every release that they were doing for production, they changed the last digit on the HVIN. So it was like A, B, C, D. And they didn't realize they couldn't do that either because in their mind, they had the model number on there, but they were changing it. So we had to file a Class 1 permissive change to add the ones they had been using, and then moving forward, they decided to just use 1 main HVIN to avoid any problems. And software changes. So when it comes to the software, this can affect everything on the transmitter. And so you can see all kinds of different failures that may occur that may not really be true failures because of the software. So many times when performing the audit testing, we find that the output power settings are either much higher or lower than what the original results were. And this can be considered a failure even if it's meeting the limits because there's such a big difference. So it's important, very important, that you document the software settings used during the original testing. So that way when it comes to surveillance, they can do the same thing. And then harmonics and spurious emissions may have a significant difference, if it's more than 3 dB typically, between an audited sample and the original sample. So if the power settings are higher, then this may affect the emissions or the band edge. So it's very important to document this and make sure that what you're providing for surveillance is representative of what was submitted and used during original testing. And then, of course, the band edge failures. And this is usually because of the power settings and occasionally because of design issues. And in our industry, I put these acceptable tolerances. This isn't really documented anywhere except for the radiated in the KDB. And in the footnote, they do have a note in there that says if it's under 3 dB, you don't need to file a Class 2 permissive change. So we allow for conducted testing 1 to 2 dBm. But for radiated, if it's more than 3 dB, usually we need to look at it a little bit further, find out what's happening. So here's some examples of some software and configuration changes that resulted in failures. So we had a sample that had a much higher output power, about 6 dBm than the original, and it was failing the band edge limits because of the power. So during the investigation process, the manufacturer realized that they actually had the original sample, and they realized that the engineer who configured it didn't ground the antenna terminal. So all the original test data was invalid because it wasn't true readings. And so they didn't realize that there were failures or that they needed to reduce their power. And so everything had to be redone. They had to redo all testing and certification for that product. And they had to recall those units and replace them. So that was a big a big problem for them. Another issue we came across was there was a device that was failing the 15.231 fundamental limit by about 5 dB. And, during the investigation process, we realized that the test software configuration was set so much higher than what the original test software configuration was. Luckily for them, the manufacturer, they hadn't sold these units yet. So all they pretty much had to do is make sure that once they did go into production, that they were using the software settings that was done for audit and not done for the original certification. So this concludes my presentation. I just want to say that I hope that you take this information and use it for any position that you're in. If you're the test lab, if you're in a test lab, you have the project managers who may be dealing with the customer. You have an engineer who may or may not interface with the manufacturer. So whatever level that you're at, it's important that you work as a team, that you don't just get stuck in, well, I'm just the engineer. I don't have to worry about anything after I show compliance, or I'm the manufacturer and, everything's fine. I have passing results, So I just hope that you can see this from different perspectives and how changes that you make or information that you leave out during the original process can affect it in the long term. So be prepared, educate yourself, ask questions, provide clear details, work as a team, and ask for help if you are unsure or you're overwhelmed by these surveillance requests. And then, manufacturers, make sure that you talk to your agent, the test lab, and find out what your responsibilities are, what the parameters are for surveillance, what their process is for that, if there's any costs associated with surveillance testing, and make sure that your contact information is up to date for the FCC and ISED databases at all times. That's very, very important. And then agents and test labs, be sure to inform your clients of their responsibilities after certification. Just keep that communication open and, and let them know what to expect if their device is selected for audit. And I'm happy to take any questions. If not, you can email me, and here's my email information.
Well, thank you, Jennifer. I did just get one question, and I'm going to go ahead and read it. I feel like it came to me privately. So here we go.
Okay.
The question is the surveillance process also applicable for non-intentional transmitters placed on the U.S. market?
Now, if you don't have certification for your product, then you're not going to be audited. This is only for certified products.
All right. That is actually the only question I see. I want to go ahead and say, though, you did an excellent job explaining your presentation, so that could be why there's no questions, because I was really intrigued and learned some new stuff, and now I'm glad it's recorded so I can go ahead and share this with us here at Washington Laboratory. So you did an excellent job with explaining.
Well, thank you.
So her email, Jennifer's email, is there in case you do have questions later that might pop up or come up. And I know she's very responsive as responding quickly, and she will answer that question. I did get a question just now regarding the presentation. Yes, so I send the recording and the presentation to all that have registered. I normally do it a day or 2 business days after the live event, so no later than next Tuesday you should have this presentation. If for some reason you don't, please send me an email, and I'll make sure you get it right away. So again, thank you so much, Jennifer, for taking the time out to enlighten us about markets, North America Post-Market Surveillance Introduction. This will wrap up our 2020 webinar series. I really hope everyone found these webinars informative and has enjoyed them as much as I did. We are currently developing our 2021 webinar series with finalizing some dates and times with the presenters. But if you haven't already done so, make sure you visit our website to subscribe to our Washington Labs Academy to receive updates. This is easily done by visiting WLL.com. You want to click on that training tab in the upper right corner and then go ahead and fill in your information where you see sign up for updates. On behalf of the Washington Labs Academy, I would like to thank you all for attending. I'm going to go ahead and now end the event, but please enjoy the rest of your day and most importantly, be safe and happy holidays and a wonderful new year to you all. Thank you so much. And again, thank you, Jennifer.